Our last lesson will focus on counting and the probabilities that are associated with it. When we count things or we order things in a certain way, all we're doing is we're multiplying different possibilities. And so what that means, if you look at example one, is this. It says, suppose the state has license plates that display 7 numerals. How many different 7-numbered license plates are possible? Well, here's how this works. We know that there are 7 possible combinations. So if you look here, in the first spot, you can have either the number 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, single digits. So there are 10 single digits. So here, there are 10 possible ways to put a number here. Next number, there's also 10 possible ways. Next is 10 all the way down to the 7th number. So all we have to do is just multiply these. We can multiply them in sequences like this. And so this is equal to 10 to the 7th. Or there are 10 million ways 10 million ways to actually get a license plate number using that. Now, how many 6-character passwords can be made by combining lowercase letters, uppercase letters, numerals, and the characters at, $, and ampersand? So here's what happens again. We need 6-character passwords. So we start this problem by drawing 6 blanks, one for each character in the password. 2, 3, 4, 5, and 6. And now we know that in any one of these, you can have lowercase letters. How many lowercase letters are there? 26. Uppercase letters, there's also 26. How many numerals? So that's like digits. That would be 0 through 9, or 10 digits. And you have these 3 special characters you can use. So right now we have 26 lowercase letters, 26 uppercase letters, 10 digits, and then the 3 of these. So for any one of these blanks, there's a possible 65 different combinations that can, or 65 different numbers, letters, or symbols that can be used. So here's what we get. 65 here, 65 here, 65 here, here, and here. So this is equal to 65 raised to the 6th power. And you can calculate that and see what that is. So the first part of this is just simply counting. When we count things, all counting says is that however many items you have, you can always multiply those items. And here's how we write this. We say n by r times, where r is the number of repetitions. So we develop these things now when we look at those that are called permutations. And in a permutation, the order of the arrangement, A, B, C, D, is considered to be different than the order of arrangement of B, C, D, A, D, C, B, A, or anything like that. So the way this works is we use this symbol that's called a factorial now, where a factorial means you start off with a number n and you count down all the way to 2 and 1. So for instance, 5 factorial means 5 is your n, count down to 1. So 5 times 4 times 3 times 2 and times 1. And here's how this works then. So 5 times 4 times 3 times 2 times 1 is equal to 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So it simplifies to that. That's what 5 factorial is. So an example 4 says, suppose you coach a team of 4 swimmers. How many different ways can you put together a 4-person relay team? And what this means is, on a relay team, let's say we had swimmers, Amy will represent as A, Beth will represent as B, Crystal will represent as C, and Danielle will represent as D. So if these four swimmers from the race, right, the relay race, you have your backstroke, your breaststroke, your butterfly, and your free. Right now, that would be Amy swimming back, Bethany swimming breast, Crystal swimming the butterfly, and Danielle swimming the free. That would be totally different if Danielle swam back, Crystal swam the butterfly, Beth swam the breast, and Amy swam the free. Which would be different if Amy swam back, Crystal swam the butterfly, Danielle swam the breast, and Beth swam the free. So here we can see that these different combinations or these different permutations we're producing are all unique. They're different. So the way we can work this in a permutation is we have, for the first spot, there are, or actually in this particular race, there are 4 different events that can happen. So we're going to do 1, 2, 3, 4, because we're still counting the number of ways it occurs. But this time, here's why the factorial arises. For the first position, to swim this first position, which is the backstroke, there are 4 swimmers that can swim here. So you put a 4 here. Once you put a letter here, though, a swimmer person here, how many swimmers are left to choose from? Well, there are now only 3. And then once you put a person here, how many people are left here? There are now only 2. And this last one, once you use up this person, this one has to be just 1. So do you see how you've gotten to a factorial here? And this is equal to, so how many ways can we rearrange these people into these different groups? Well, 4 times 3 times 2 times 1 is equal to 24. There are 24 different permutations for this team to swim. Next example. A middle school principal needs to schedule 6 different classes, algebra, English, history, Spanish, science, and gym, in 6 different time periods. How many different class schedules are possible? Well, if I take these classes in that order right there, you could also take these exact same classes, but in a different order. So they're going to permutate the different classes that are available to us. So we have first period, second period, third period, fourth period, fifth period, sixth period, like that. So there's 6 different periods. And now, here's how this works then. How many classes are available to us? 1, 2, 3, 4, 5, and 6 total classes. So your first period class can be any one of the 6. Let's say your first period class is gym. Well, how many classes are left? 5. Let's say your second period class is English. How many classes are left? 4. Let's say your third period class is algebra. How many classes do you have left now? 3. Let's say that this one's history. How many are left now? 2. Let's say that this one is Spanish. Then your last class has to be science. And that's why this is called a permutation. And in a permutation, the order matters. We say the order of an arrangement matters, meaning that this schedule right here is totally different than another schedule we had with the exact same classes. And so this would be 6 factorial, or 6 times 5 times 4 times 3 times 2 times 1. Now, this method of ordering things leads us to what we call the permutation formula. And when we permutate things in a formula, it says on a team of 10 swimmers, how many person relay teams are there? Well, we get this new formula up here. And N stands for it's called NPR, or N permutate R things. And what that means is, N stands for the number of items you have total. R is the number of things you want to order. So on a team of 10 swimmers, how many possible 4-person relay teams are there? Our N is we have a total of 10 swimmers. We want to permutate them into groups of 4. So they want to know how many are available. So we write this as 10, 10, we say P4, or 10 permutate 4. And it's written like this: 10 factorial. So you do n factorial at the top. So whatever your n is, put it at the top. 10 factorial at the top over 10 things minus the 4 that you're permutating factorial. And so what that really means is you start off with the number of ways you can move things around, or the number of items you have available to you. So that would be 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And what you want to do is from those 10 things, you're going to look at only 4 of them. So you want to take 10 minus 4. That leaves you with 6 ways to. That leaves you with 6 factorial ways to move those 4 things around. And so at the bottom of this, 10 minus 4 is just 6 factorial. So this is 6 times 5 times 4 times 3 times 2 times 1. And again, this right here is just 6 factorial. So look what happens here. This and this will cancel. So you're left with just 10 times 9 times 8 times 7. And this is the total number of ways to permutate those things. And that's equal to 5,040 ways to arrange those different members of that swim team. Number 7. If an international track team has 8 athletes participating and 3 medals, gold, silver, and bronze, to be awarded, how many different orderings of the top 3 athletes are possible? Again, here order matters. If A gets gold and B gets silver and C gets bronze, that's different than C getting gold, B getting silver, and A getting bronze. So we need to worry about the ordering matter there. But we have how many athletes available? So our N here is 8. And our R is, we're only looking at 3 of those. So when we do this, we have 8P3. And that's equal to 8 factorial at the top over 8 minus 3 factorial. So n minus r factorial at the bottom. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 minus 3 factorial will equal 5 factorial. So that's 5 times 4 times 3 times 2 times 1. And again, here and here are canceling. It's on the top and bottom. So you're just multiplying 8 times 7 times 6. And I get 336. So there are 336 ways to rearrange those athletes like that. Now, these are called permutations. In some particular things, order doesn't matter. Some groupings, the order doesn't matter. When the order doesn't matter, we focus on what's called a combination. And in a combination, the different groupings are not unique. That means that A, B, C, D is the same thing as D, C, B, A, which is the same thing as B, C, D, A, and so forth. Because of that, we need to take out our repetitions. So if you notice this formula for the combinations start off as the permutation formula. But then we divide by an extra factor, or the ordered numbers we're taking, and that right there takes out the repetitions for us. So example 9 is an example of a combination. If a committee of 3 people are needed out of 8 possible candidates, and there is not any distinction, so we don't care about it. So that means that ABC is the same thing as BCA, the same thing as DCA. They're all the same people between the committee members. How many possible committees would there be? Well, our N is equal to 8. There's 8 possible candidates. And we're only interested in 3 of them. So R equals 3. So we're going to write this time as 8. And we say 8. A combination means you choose. You can say 8 combine 3 or 8 choose 3. Because the order doesn't matter. So 8C3, that's equal to 8 factorial over 8 minus 3 factorial, which is the permutation formula. But there's one extra step we need to do now. Let's calculate the permutations. But because permutations are unique and combinations are not, we need to go ahead and take out repetitions. And so now we're going to take out the repetitions, which are just 3 factorial. So that means that this is equal to, at the top you have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And at the bottom, you have 2 sets of factorials. 5 minus 3 factorial is 5 factorial. So this is 5 times 4 times 3 times 2 times 1. But you also have a second factorial, which 3 factorial is 3 times 2 times 1. So what cancels out now is 5 up here and 5 down there. So it's 5 factorial canceling. And then you have factors that you can combine if you want to start to cancel out. For instance, 3 times 2 is 6. This times this is 6. That cancels with this 6 right here. So now you have 8 times 7, which is equal to just 56. So factorials are nice because they tend to cancel when they're on top and bottom. Suppose that you select 3 different flavors of ice cream in a shop that carries 12 flavors. How many flavor combinations are possible? And so what this means is that if you get chocolate, a cherry, and nuts, that's the same thing as getting nuts, a chocolate, and cherries. So those orders don't matter. Because of that, it's a combination. And again, our N here is equal to, there are 12 flavors. There are, you get 3 different flavors. So that should be like saying chocolate, vanilla, and strawberry. It's the same thing as vanilla, strawberry, and chocolate. So R is, I'm looking at 3 flavors. So when I do this, it'll be 12 C3 or 12 choose 3. And so again, that would be 12 factorial over 12 minus 3 factorial times 3 factorial. And so 12 factorial is 12 times 11 times 10 times 9 times 8, all the way down to times 2 times 1. I'm not going to write all those. Actually, I want to write it like this. Times 3 times 2 times 1. The bottom would be 12 times 3 factorial. Well, this is just 9 factorial. So look here, we're going to start at 9 times 8 times all the way down to times 3 times 2 times 1. So that's 9 factorial. And 3 factorial is 3 times 2 times 1. So look again, 9 factorial canceling. The bottom is 3 times 2 times 1, that's 6 at the bottom. Top is 12 times 11 times 10. So 12 times 11 times 10, that is 1320 divided by 6. There are 220 ways. This is equal to 220 ways to go ahead and pick your flavors.